Hello good people, I'm going to talk about naming of organic compounds with a specific focus on alkenes. We can use the same guidelines we've used for alkanes, but as you might suspect, there is more to it. Let me start by drawing a pentene that we have encountered earlier. So here are my 5 carbons, and I'm going to add a double bond here at the start between carbon 1 and 2. However, this is not the only pentene I can draw. Alright, here are my 5 carbons, and this time I'm going to shift the double bond between carbons 2 and 3. These two compounds are structural isomers. They have the same molecular formula, C5H10, but their structures are not identical. And because they are not identical, they will have different names. How do I name them? Well, as I have said before, I follow the same guidelines, but this time there is a sub-rule. It tells me that if I have a carbon-carbon double bond, the numbering priority is given to that double bond. What do I mean by that? Well, if I look at the if I look at the compound on the left, I'm going to start the numbering from left to right rather than from right to left. Because if I do it from left to right, the carbons of the double bonds end up with the lowest number. What is the name of this compound? It has 5 carbons and a double bond. Therefore, it is a pentene. The double bond starts on carbon number 1. So I'm going to call this 1-pentene. The 1 indicates where the carbon-carbon double bond begins. Please note that there is an alternative way to name this compound, and that is to start with the prefix for 5 carbons, so pent, and then to indicate that on carbon number 1 we have a double bond. And so this compound can also be called pent-1ene. In a similar fashion, the compound on the right is also a pentene that is numbered from left to right. This is done in order to make sure that the carbons of the double bond end up with the lowest numbers. The name of the compound is 2-pentene or pent-2ene. The 2 indicates the location of the double bond. What about the following compound? So again, I'm going to draw 5 carbons in a chain. Here they are. And this time I'm going to place the double bond here. Is this a new compound or something that we already had? To answer that, I need to number the carbons. A common mistake would be to number them from left to right, and so we would end up with a carbon-carbon double bond beginning on carbon number 3, and we might call this 3-pentene. However, this ignores the sub-rule in green. Numbering priority is given to the double bonds. This means that I need to number the carbons from the side that will give the double bond the lowest numbers. Let me get rid of these numbers and number the carbons from the side that will give the double bond the lowest numbers. And now I have the double bond between carbon 2 and 3. That is something that we had here on the left, or in the middle if you like. So this compound on the right is also 2-pentene. Let's play with this a bit more. I'm going to draw another pentene, so I need 5 carbons in the chain. I'm going to place a double bond here, but I can also have compounds with 2 double bonds. So I'm going to add another double bond here. What is the name of this compound? Firstly, I'm going to number the carbons so that the double bonds end up with the lowest numbers. I'm dealing with something that has 5 carbons, so I can use the prefix penta. And because I have double bonds, I need to indicate that this is an alkene, which means I will have the suffix -ene. However, I need to indicate that there are 2 double bonds. There are 2 -enes. So I'm going to use the prefix for 2, which is di. And now I can say that I have a pentadiene. To make everything nice and neat, I also need to indicate the location of the double bonds. and they start at carbon 1 and 3. This becomes 1,3-pentadiene. The alternative name for this compound is penta-1,3-diene. The fun does not stop here. What if I have an alkene that also happens to have a methyl group attached to it? What would be the name of this compound on the left? I follow the guidelines. I'm going to start by identifying the longest continuous carbon chain that also includes the double bond. In this case, the longest continuous chain contains 6 carbon. So I can use the prefix hex. I am dealing with an alkene, so this becomes a hexene. However, the longest continuous carbon chain also has a methyl group. This will be a methylhexene. Where are the double bond and the methyl located? To answer that, I need to number the carbons. Now I have a decision to make. From which side should I number it? If I number it from right to left, methyl will end up on carbon number 2. If I number the chain from left to right, well then the double bond will end up on carbon number 2. Which is the correct option? I look at the subrule in green. Numbering priority is given to the double bonds. This means that if I have to decide what should get the lowest number, a methyl group or a double bond, it is the double bond that wins. Let me quickly number the carbons from left to right. The priority has been given to the double bond, and so the name of this compound is 5-methyl-2-hexene. Alternatively, we could also call it 5-methyl-hex-2-ene. Before you are overcome with the urge to throw something through your computer screen, let me say that is all for now, and I will see you on the flip side.